Hey guys, you might notice a little change of scenery. I had to come up to campus today to make these videos. Today's videos are going to be on turbochargers and diesel exhaust fluid. This one is going to be, I believe, 869. It's on turbochargers. So we're going to talk a little bit about some common problems you may find on a turbo. It's a lot of mechanical issues with turbos, typically over the electrical side of things, at least in my experience. So I'm just kind of going to run you through some things to look at. We have a turbo vehicle that we'll be looking at on the lift. It is a 2014 Ford Fusion with a 1.5 liter turbocharged engine. So if it asks you to look anything up in ALLDATA, that's the vehicle we're going to be using. So I'll show you, there's a couple of things we got laying around on the cabinets here, but we'll kind of do a little tour of that vehicle, and then I'll show you a couple other turbos on the bench, and we'll kind of look at some problem areas for those things. And then we will move on to the exhaust fluid sheet. All right, so we've got our Ford up on the lift. We're just going to do kind of a little bit of tour of this vehicle, see what we can see for now. It doesn't really look all that different when you first open the hood, but a couple of things to note you'll notice that are different about turbo cars versus naturally aspirated cars. Look at the ducting. Like this right away tells me that this is probably a turbocharged vehicle. It's going to have a lot stiffer ducting going from the throttle body or going to the throttle body. It's going to be a lot more rigid. It's not going to be that flexible rubber kind of stuff, because if you remember, we have pressure in here. So it's got to be a little bit stronger to withhold the pressure. And you'll see we'll have a little bit different style clamps. You know, they're still what's called like a worm gear style clamp, but they are a little bit different. Looks like here we've probably got a pressure relief or a blow off valve, something like that. If you're building a bunch of boost and you get out of the gas and snap this throttle shut down here, we're gonna blow a little pressure out of there, so we don't end up over pressurizing our system. There's not a whole lot else to see up top. This turbo is in the back, way down low, so we're gonna lift this thing up all the way and see what it looks like on the bottom side. All right, I know this isn't a very good view, but we're looking at the bottom side of our turbocharger here. We can't really see it from the top. It's kind of down low on the side, so it's really hard to see from the top. What we're looking at here is the exhaust side. This is where we are hooked up to our exhaust outlet, to our catalytic converter, and then out to the back of the vehicle. We want to make sure we don't have any kind of leaks right there, any kind of soot buildup or anything like that you'd see coming out of there. Now this pipe right here that's got the bends in it, 2 bolts right there, that is our oil return to the pan. Let's see if we can find it here. There we go. It comes right into the side of the block. That hot oil comes out down this tube and back into the pan, where it gets cooled back off and recycled back around. If we look up a little higher, these 2 silver pipes right here, those are our probably going to be our feed pipes. Those may be oil or coolant on a Ford. I'm not 100% sure. Typically there's coolant going in there, but there's also going to be an oil feed. So we're looking at this thing for leaks. One thing to note on the oil feeds, I know on the GM turbos we were having problems for a while, having mechanical failures. The oil feed lines for those things were so small that they get full of they just get full of crap, and they'd stop feeding oil to those bearings. And once you lose oil to those bearings, your turbo doesn't last for long after that. We got the duct here. Make sure that those clamps are tight, everything looks good. You don't have a whole bunch of oil leaking out of those. And really, that's about it. When I looked at this vehicle, I was a little surprised. This doesn't have what's called a charged air cooler or an intercooler. You may see ALLDATA or service information abbreviate these as a CAC, and that is charged air cooler, so look out for that. But this vehicle just doesn't have one. A lot of times we'd get vehicles in with check engine lights And under boost codes, a lot of running through those charts is making sure we don't have any air leaks anywhere, and a good spot for that is a charged air cooler. But this vehicle doesn't have one. It's pretty simple, so there's not a whole lot to it. But really, we're gonna go look at a couple of these on the bench and look for, I'll show you a couple other spots to keep an eye out for. So this is one of the cabinets we have in the fuel systems room. We got a whole bunch of turbos in here, and if you see that big giant supercharger back there in the back, from what I understand, that actually goes on the dragster. They need a couple of carburetors to run that thing, and but that's what it's for. While we're talking about turbo diag and all that kind of stuff, as far as superchargers go, at least in my experience, the only problems I've ever had is either going to be an underboost condition caused by, you know, charged air cooler leaks or something like that, or the Camaros that were supercharged. We saw those for a while. They'd make a lot of noise, and they'd get some slop in them. And really, the diagnosis on those is you grab the front pulley and you kind of shake it back and forth, and we'd have a lot of movement. They were getting pretty loose. This one's real nice and tight. If you go back and forth, there's just a tiny little bit of movement in there, but those Camaros, you could move quite a distance before you'd hit the other side, and they'd make a lot of noise, sound like an engine knock. So we were putting superchargers on those. But let me grab a couple of these turbos and we'll take a look. Before we start on that, here's an example of some stuff that you might see in a charged air cooler setup. These look a little bit more like performance parts. They're all nice and shiny. Typically, factory stuff will just be like aluminum. But we're looking for steel pipes like this you'll find, or maybe that hard plastic like we saw before. And then we're going to have this kind of flexible rubber and clamps at our 90s. So charged air cooler, we just want to make sure that these things are sealed up and not leaking air anywhere. One thing you could do, maybe if you suspect, you could either do like a smoke test, like we talked about before, or soapy water, things like that. I know some of the vehicles I worked on in the past, like the Duramax, has special adapters for testing the charged air system, where you put a plug in one end and the other end has an air fitting on it, and you charge that thing up full of air and try and find leaks. So if you got a small leak, maybe some soapy water will help you figure that out. But this is kind of what we're looking at as far as charged air goes. I've got a bunch of turbos here, so we'll start at the end. This one looks a little older, and it's the smallest. I don't really know what it's off of, but it's pretty small. It's pretty basic. Like I said, it's probably been around for a while. But honestly, nowadays, with our small cars like that Ford we were looking at, and you know, some of the Chevys and stuff that I've worked at, you're expecting a turbo about this size, or maybe the size of this next one. This one is probably maybe even a little bit more common. It's just a touch bigger, but it's got a big flange on it. It's probably going to bolt right to a manifold. A lot of the ones that I've dealt with actually have the manifold just made on right here. So this whole thing just bolts right to the cylinder head. It's all one big piece. But like I said, this one's just a little bit different. So this is where our exhaust is coming in. We want to make sure we don't have any leaks there or anything. So we've got wastegate and wastegate actuator. These are run off vacuum. Let's see here. So this is probably going to be an oil feed. Oil return out of the bottom. We've got more, probably a coolant in and out. But really, a lot of things I've seen on these is leaks or, you know, catastrophic failure. You want to look in at both of the wheels on here. You want to stick your finger in there and make sure that they turn nice and smooth. They're not touching anything as they move around on both sides. If you can, you want to reach in there and try and give that a move. You don't want any movement side to side or really much in and out. So they should be pretty secure in there. If you got a bunch of slop in there, you're just kind of asking for problems. So this one feels good. That's kind of how we want it to be. This next one, This one looks a little bit more like a performance turbo also. See, it's all nice and shiny. Typically that's how you can tell performance parts, because they look cool. This one says Hellion on it, so that's how you know it's good. But it's going to be pretty much the same setup. It's going to have ins and outs for oil and coolant. We got some big old wheels in here. This one spins a lot easier than the other ones even. But we want to it's got a little bit of side to side. That's this way, in and out. We don't want any really much up and down. I mean, it's going to have a tiny little bit of play in the bearings, but like if I can move this up a little bit and still spin it and not contact anything, and it still feels good, that's probably just kind of the way it is. This one's got a little bung here for probably some kind of temperature sensor, something like that. And then we'll clamp our exhaust right onto this flange. But it's the same thing on both sides. Now this one down here, it looks like it's off of a Duramax. Obviously it's missing some pieces. It's missing a whole half of the housing. But you can kind of see what we're looking like as far as mechanical damage goes. So when things go wrong, they go pretty wrong, and this thing will get beat up pretty bad. The bearing actually still feels good. I'm not really sure what exactly happened to this. Maybe got some foreign material in here, some debris or something like that, and it beat this wheel up. But this is the biggest one I could find in the cabinet, and this one is off of an early Duramax. And the way I can tell you that, sorry, I know this video isn't perfect, is this little solenoid right here. That is a oil flow control solenoid. I don't know if you guys remember from our PowerPoint, but these Duramaxes have variable position vanes in them, so we can kind of fine tune this turbo a little bit more. Now the ring with the vane in this whole housing, I'm not really sure where it's at. I wish I could show you guys that. It's pretty cool to see. But like I said, this functions just like all the rest. It's going to have oil in and oil out and some coolant. This one's just got this extra solenoid because it's a variable vane. But honestly, in my experience, we get a lot of underboost codes for turbos. And you're going to look at the charge air system and maybe the wastegate for operation, something like that. And if you can't find anything wrong with these things, you're going to put a turbo on it. There's going to be some electrical solenoids you may need to test, or you may have to get out a vacuum pump and hook up to your wastegate actuator and verify your wastegate's operating properly. Again, we want to check the bearings, make sure we don't have any leaks. Like if we have a bunch of oil pouring out of either sides of this, we'd get that sometimes. You pull off the hoses off of here, and it's got quite a bit of movement in it. That's definitely something you don't want to see. That's bad news. But we don't want a bunch of oil pouring out of here. That can cause some issues. So yeah, definitely if you see something like that, you're probably going to hear it first, but that's not good. So you'll see a fair amount of things like that. Typically on modern turbos, so like this one, you can see it's got some adjustment in the wastegate. And aftermarket ones are probably going to have that also. The more modern ones like this, they don't want you really to adjust these. These are going to be set at the factory, and you leave them alone. There's not really anything you do there to make an adjustment. That may not be true for every manufacturer, but all the ones that I've encountered recently, they don't want you to mess with that. Now, if you're dealing with performance and stuff like that, then yeah, that's something you're probably going to be fiddling around with. How far or how much your wastegate is opening and that kind of thing. So. But that's just something you'll kind of have to play around with. But really, like I said, I mean, in my experience, a lot of turbo diag is a good visual. If you do have a code that is directly calling out a solenoid and you need to do some electrical testing, then that's what you need to do. But a lot of times, if you get an underboost code, 9 times out of 10, you're going to wind up putting a turbo on it. But look up in ALLDATA for the diagnostic procedure for checking out the turbo on that 14 Ford Fusion with the 1.5, and see what you can come up with, and we'll move on to the next sheet.